Hey guys, so we are going to cover the last lesson of the chapter today, lesson 3.6. Let me present my screen and we'll get started. Okay. All right, so we're going to be looking at quadratic inequalities in two variables, quadratic inequalities in one variable. So an inequality of the form y is less than ax squared plus bx plus c, y is greater than, y is less than or equal to, or y is greater than or equal to. All right, and then quadratic inequalities in one variable, it just means that instead of having both x and y, you're just going to have x's, and the other side of the equation is going to be set equal to 0. Okay, and you can see examples of both. So graphing quadratic inequalities, the nice thing is we've already graphed linear equations and linear inequalities in Algebra 1. And then we've been spending a lot of time this year graphing quadratic equations. So graphing quadratic inequalities is kind of taking the information we already know about graphing quadratics and graphing inequalities from Algebra 1 and merging them together. So a lot of this will seem familiar. So to graph a quadratic inequality in one of the following forms, it says follow these steps. First, you're going to graph the parabola. Okay, so instead of having the inequality symbol, just replace it with an equal sign and graph the parabola. Now, just like when we studied inequalities in Algebra 1, if it has just a less than or greater than symbol with no bar underneath, that's going to be a dashed parabola, because that means that the points that are on the actual parabola aren't solutions, okay? Now, if there is a line underneath the inequality, then it's going to be a solid parabola. Then you're going to test a point inside the parabola to determine if the point works, and that'll help us determine where to shade. I also kind of have a trick to help us with that as well, which I'll show you as we go through the problems. So shade the region inside the parabola if the point from step 2 is a solution. Shade the region outside if it is not a solution, because where you're shading, that is where your solutions are. Okay, the first 4 problems say, match the graph with its inequality, explain your reasoning. So by process of like elimination, just kind of noticing some things. Okay, first off, I noticed that B and D have negative A values, whereas A and C have positive A values. So I can already kind of determine just by looking at that my answer for 1 and 2, this is either going to be, ignore that, A or C. This is going to be A or C, because it's opening up, positive A value. That means the ones opening down, this is going to be either B or D, and this one's going to be B or D. Okay, now they're both dashed lines, which makes sense because they both have the no bar underneath. Here I have solid lines. So this is where I'm going to teach you the trick, okay? The trick is I'm going to tell you to put your pencil where the parabola crosses the y-axis. So that would be like this point right here. Okay, that would be like your y-intercept, which happens to be -8, right? Because the c value is the y-intercept. So there's the y-intercept. And then I'm going to have you read just this part of the inequality. Okay, it says y is less than. Okay, y is less than. If I'm on the y-axis, where are the y values less than this one? Where are the y values less than -8? They're less if you move down. And if you move down, you're going to be on the outside of the parabola, so you would shade this region. So that actually means that A is the correct inequality for this graph. Okay, now by process of elimination, that means C is the correct one for this, but let's understand why. If I read this part of the inequality, it says y is greater, y is greater. Go to the y-intercept again and ask yourself, where are the y values greater? They're greater if you move up. If you move up, you're going to be inside the parabola, and this is where you would shade. So the answer here is C. Okay, same trick will work for the next 2. Here's my y-intercept, right? And here's my y-intercept. Okay, this one says y is less than. So if I'm on the y-intercept, where are the y values less? They're less here. Okay, if I move down, I should shade this region, which I didn't, All right, so this is not the graph for B, so that means this one should be, but let's understand why. Y is less than. Here's -8. Where are the Y values less? They're less if you move down. You would shade this region. So this one is B. And then if I read this part of the inequality, it says Y is greater. Where are the Y values greater? They're greater if you move up. You'd be shading on the outside. So that one is D. I will explain that shading trick again when we do some graphing problems in a moment, but hopefully you're starting to understand because that saves you a lot of time. Because the other option is to taking a test point, plugging it in, doing a bunch of calculations to make sure the test point works. This trick is a lot faster and, works every time. So it's a good trick to know. All right, so now we're going to graph some inequalities. All right, so we're just starting with single quadratic. We're not dealing with two or anything like that, just single quadratics. So let me first make my X and Y axis nice and dark. Use my pen over here. So here's my Y axis. Ooh, try to get a straight line. Here's my X axis. Okay, so for this graph, if I want to graph it, I can see that my K value is 2 and my H value is 0. So that means the vertex is at 0, 2. All right, so I'm going to go up 2 units. My A value is a +1, so it opens up and there's no vertical stretch or shrink. So there. And then out 2, up 4. Out 2, up 4. Now, because there's no bar underneath, that's how I know I'm going to do a dashed parabola. So dashed parabola because there's no bar underneath. Okay. And then finally, read this part of the inequality. It says Y is less. Where are the Y values? Go to the y-intercept. Where are the Y values less? Are they less if you move down or up? They're less if you move down. If you move down, you're going to be on the outside of the parabola. So this is the region that you would shade. All of the points in this region work in that inequality. All right. The next one, H and K values are both 0. So my vertex is on the origin. This parabola opens down and has a vertical stretch of 5. So I'm going to put my x-axis a little higher. All right. So I said it has a vertex at 0, 0 because the H and K values are both 0. It opens down, has a vertical stretch of 5. So it's out 1, down 5. Out 1, down 5. Is it a solid parabola or dashed? It would be a solid because of the bar underneath. So solid parabola. Go to where the go to where the parabola crosses the y-axis, which happens to be the vertex, and read what the inequality says, just this portion of it. Y is less. Y is less than or equal. Where are the Y values less? Are they less if you move down the y-axis or up? They're less if you move down. If you move down, you're going to be inside the parabola, so you shade this region. Okay, all the solutions to that inequality are inside the parabola. All right, let's move on down. All right, so my X and Y axis again. Okay, this next one, H and K. My vertex is -4, -1. Okay, so -4, 1, 2, 3, 4, -1. Oh, I may have wanted to. Let me see how this graph is going to look so I know if, it's okay. I can leave it there. I didn't know if I was going to want to move my X and Y axis a little bit, but that's fine. It's opening down because it has a negative A value of a 1 and doesn't stretch or shrink. So the pattern is just out 1, down 1, out 1, down 1, and then it would be out 2, down 4, but I'm just going to do that. Is it a solid or a dashed parabola? It is a solid parabola because the bar underneath indicating that all the points on the parabola are solutions. All right, now this one is a little more tricky because we don't actually have the y-intercept graphed, but imagine that the y-intercept, if I extended my parabola, the y-intercept would be like about there. Okay, right? If I was to just pretend that it goes all the way down. So if this is the y-intercept and you're reading what this says, y is greater than. Where are the y values greater? They're greater if you move up. And if you move up, you're going to be outside the parabola. So you shade this region. Now, if how I'm explaining where to shade is not making sense to you, I will show you another option for this problem. After you graph your parabola, pick any point. I typically tell students pick 0, 0 because it makes the math really easy. Pick any point either inside or outside the parabola. Okay, I'm going to pick 0, 0 whenever I can. I'm going to plug 0, 0 into the inequality and see if it works. So it would be 0 for the y is greater than or equal to negative 0 for the x plus 4 squared minus 1. So 0 is greater than or equal to negative 4 squared minus 1. 0 is greater than or equal to negative 16 minus 1. 0 is greater than or equal to negative 17. Is this true? Is 0 greater than or equal to? It's true. Since the coordinate 0, 0 worked, and since that point was outside the parabola, that's how I knew to shade this region. If 0, 0 did not work, I would have shaded under the parabola. So this is the other option of how to figure out where to shade, but I think my little trick is much easier. So hopefully it makes sense to you. Okay, so this next equation is in a standard form instead of vertex form. All right, so in standard form, I know how to calculate my vertex. To calculate your vertex, let's do the work over here. Vertex, it's x is equal to negative b over 2. So x is equal to negative 4 over 2. So x is equal to negative 2. Okay, and then to find the corresponding y, I'm going to plug in that, write down the wrong number, plug in that negative 2 into the original equation. So it's 4 times negative 2 squared plus 4 times negative 2 plus 1. That's 4 times 4 minus 8 plus 1. That's 16 minus 8 plus 1. That's 8 plus 1, which is a 9. Okay, so your vertex is negative 2, negative 9. I may need to move or negative 2, positive 9, sorry. Negative 2, positive 9. Negative 2, I'm probably going to have to move my x-axis. All right, let me go down. I'll go down here. Okay, so negative 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then, why does that not really make sense to me? Because it doesn't match what I have. Did I make a mistake? I'm not sure where my mistake is because negative 2, 9 doesn't look to be the vertex that I drew. It is a point on the parabola though. All right, let's just keep on going. So this one opens up as a vertical stretch of 4. The y-intercept is 1. Yeah, something's not right with my vertex. I made a mistake on my vertex, but that's okay. The y-intercept is 1, okay? Your vertex should be down here. I don't know where I went wrong, guys, but we're just going to sketch this one. It should be a dashed parabola. And if this is the y-intercept, and I read this as y is less than, I would move down, which means I would shade outside my parabola. So I somehow made a calculation error. I'm sure you guys probably see it. I was actually going to skip this problem anyway because I want to move on to others. But as long as you understand the shading part, that's really what's important because the graphing part is old news. All right. Let me move down. Okay, we're actually going to skip over 9 for now. We'll come back to it if we have time. Graphing the system of quadratic inequalities. So the nice thing is we are going to do exactly what I was just showing, but we're going to do graph 2 parabolas on the same and look for where the shading overlaps. Okay, so this could get kind of messy, but we'll do our best. All right, so let me make my x-axis and my y-axis in the middle. Okay, so for the first graph, it's y equals negative x squared. The vertex is 0, 0. It opens down. There's no vertical stretch or shrink. So out 1, down 1, out 1, down 1, out 2, down 4, out 2, down 4. It's a solid parabola because of the bar, right? I wrote it as an equals, but I'll change it now. It's less than or equal to. It's a solid parabola. And if I go to the y-intercept and I read this portion of the inequality, it says y is less. Where are the y values less? Up or down? They're less if you move down, so you would shade this region here. Okay. Now the other parabola is y is greater than negative 3x squared plus 3. My vertex, my h and k value, 0, positive 3. So 0, positive 3 means you're shifting up 3 units. It's going to open down and have a vertical stretch of 3. So I go out 1, down 3. 1, 2, 3. Out 1, down 3. Then I would go out 2, and normally I go down 4. This time I would go down 12. So it's going to kind of get like really skinny and go inside the other parabola. Okay, so it looks something like this. Oh. Is it dashed or solid? I'm getting ahead of myself. All right, this is what I'm going to do. It should be a dashed line to indicate that that was supposed to be dashed. I'm just going to go like this because if I erase, I'm going to have to do the whole thing over again. So that's my indication that I was supposed to dash it. I'll dash the other side. Okay. And then the y-intercept is here at the vertex, and this is read y is greater. Where are the y values greater? They're greater outside the parabola. Okay, so where do you have, and it's going to be hard to see on my graph, but where do you have both red and yellow shading? Okay, you have red and yellow shading. I'm going to do it in black. In between right here, right in here. This is where your yellow and your red overlap. Again, if you have graph paper and you can use pencil and do some erasing, it's a lot easier, but you're looking for where the shading overlaps. In fact, you can even, maybe in Algebra 1, your teacher said, now go back and erase everything you don't need. It would be very hard for me to do that right now, but you'd want to erase everything and just leave where they overlap, okay? All right, the next one. Okay, so we have y is greater than or equal to x squared plus 5x, and we have y is greater than or equal to x plus 2 squared minus 1. So for this one, the vertex is -2, -1. It opens up. There's no vertical stretch or shrink. So -2, -1. And it's out 1, up 1, out 1, up 1, out 2, up 4, out 2, up 4. And is it a dashed or a solid parabola? It would be a solid parabola. You go to where the parabola hits the y-axis, which is right here. You read what the inequality says. It says y is greater. Where are the y values greater? They're greater up. All right, so you would shade inside the parabola here. Okay, for the next one, this is not in vertex form. This one is in standard form, so you have to calculate the vertex. Okay, I'm going to kind of cheat and tell us what the vertex is. The vertex is -2, -1. Oh, no, it's not. The vertex, it's in between. It's going to be down here. I'm going to plot a point at 0, 0, because that's the y-intercept. Then I'm going to plot a point at -5, 0. I'm going to plot a point at -4, -4. And -1, -4. And then we're just going to sketch it from there. It is a solid parabola. I'm taking shortcuts tonight, guys. I'm not going to calculate the vertex by hand every time. All right, and you want to shade y is greater, so the y values are greater inside the parabola. All right, so you shade inside the parabola here. So where does your shading overlap? Well, your shading overlaps just inside of this smaller parabola up here. So that's where your solutions are. Okay. All right, we're going to move on to the next type of problem. There's another graphing problem if you want more practice. And just to give you an idea, if you want to do that one, this one, you have to change the y-axis to, I think I was counting by 5s because, well, you'll see if you want to go through it. But when you graph, you're going to have one parabola open this way. You're going to have another parabola open this way. And the shading should overlap in between. So if you want to try that one and see if you get the correct answer, that would be a good idea. All right, so we're going to move on to, I think these are the last 3. Yep, these last 3 problems, solving the inequalities algebraically. Okay, so for these, we're going to do number 13 first. What you want to do is isolate the x. Oops, I need to get my pen. Okay. Isolate the x squared, so I'm going to divide both sides by 16. So just treat it like an equation, but don't forget when you multiply or divide by a negative, your inequality symbol flips. So you have x squared is greater than 100 over 16. Now take the square root of both sides, say x by itself. So x is greater than plus or minus the square root of 100 over 16. And actually, guys, I should tell you, for these problems, and I'll explain why in a second, we're going to change the inequality symbol for now. We'll go back to the inequality in a minute, but we're going to change the inequality symbol to just an equal sign. And just work through it like an equation for now. So equals plus minus. Now, luckily, both of those are perfect squares. So it's x is equal to plus minus 10 over 4. All right, which can be, I'm just going to pull my screen down, but I can't, which can be simplified to 5 over 2. All right, so what you're going to do from there is we're going to actually plot on the number line. All right, so if you can imagine, because what we just found, the x-intercepts, right? If we were to graph this parabola, imagine that you have one x-intercept at -5 over 2 and the other x-intercept at +5 over 2. So 5 over 2 is 2.5, right? So 1, 2, 3. So this would be 5 over 2 right here. So I'm going to plot an open circle because there's no bar underneath my inequality symbol. And then 1, 2, 3. So this is negative. I'll just write it up here. This is -5 over 2. And this is +5 over 2. Okay. Now, what you have to do now is figure out, am I supposed to shade in between those 2 points to the right of those of this point and to the left of that point? Where's the shading? Okay, so what you're doing is you're only visualizing part of the parabola. If you can envision a parabola that's opening up something like going through the x-intercepts right there. Okay, this is what we have, and we need to decide, are we shading inside the parabola, in between, or am I shading outside of the parabola? Okay, so we can take a test point like 0, and that makes the math really easy. If 0 works, then we'd shade inside, we'd shade in between. If 0 doesn't work, you shade on the outside. So if you plug 0 into the original, 16 times 0 squared is greater than 100. That's 16 times 0 is greater than 100. That 0 is greater than 100. That does not work. Since 0 does not work, that means I'm going to shade out here. Okay, so an open circle on 5 halves, shade to the right. Open circle on -5 halves, shade to the left. All right, let's do another one. Okay, so again, let's first, I'm going to be more systematic about it this time. Let's first change the inequality into an equal sign. Now for this one, because there's both an x squared term and an x term, instead of over here we solve by square root, okay, we isolated the x squared, but if there's both the x and the x squared, you want to set it equal to 0. So I'm going to move the 11x over by adding it. So 2x squared plus 11x minus 6 equals 0. And then I'm going to try to factor it if it can be factored, okay? So there's no GCF. I'm going to have to do some guess and check, unfoil it, right? Reverse foil. Two numbers that multiply to 2x squared are 2x and 1x. Two numbers that multiply to 6, well, it could be a 6 and a 1, right? I could have a 6 here, a 1 there, or maybe a 1 here and a 6 there. It could be a 2 and a 3, or a 3 and a 2. So that's where the guess and check comes into play. I'm going to put the 1 and the 6. Now, the way you guess and check is you check your outsides, that multiplies to 12x, and your insides, that multiplies to 1x. I need an 11x when I add those. Well, in order to get an 11x, the 1 has to be negative, and the 12 has to be positive, because a 12 minus a 1 gives you an 11, okay? So now I'm factored correctly. Then I'm going to use a zero product property. I'm going to set both of those equal to 0. So 2x minus 1 equals 0, and 1x plus 6 equals 0. So I have 2x equals, add the 1 over, 1x equals, subtract the 6 over. So x equals 1/2, and x equals -6. Okay. So again, if I was graphing, I'm going to have my number line. I'm going to have an open circle because there's no bar under the inequality. So an open circle on -6 and an open circle on 1/2. So here's 1, 2, open circle on 1/2. And then -1, -2, -3, -4, -5, -6, open circle on -6. All right. And then you're going to test a point. You can test a point in between or to the right or to the left. It's up to you. I always like to test 0 because it makes the math easy. So I'm going to write the original problem down. 2x squared minus 6 is greater than -11 times x, and plug a 0 in for all the x's. So 2 times 0 squared minus 6 is greater than -11 times 0. So that's going to be 0 minus 6. That's -6 is greater than -11 times 0 is 0. So is -6 greater than 0? No. So if 0 does not work, that means you want to shade to the right and to the left, okay? You do not want to shade where 0 lies, okay? So again, if this was a parabola, that means we're shading on the outside of the parabola. Okay. All right, and then last one. Pull it up. I don't know why I didn't pull it up further to begin with. All right, so for the last one, again, I'm going to change it into an equation to start, changing the inequality symbol into a equal sign. Since this has both an x squared and an x term, oh, I set it equal to 0 and it's not equal to 0 yet. I was thinking about what I need to do next. I'm going to set it equal to 0, so I'm going to subtract 1 from both sides. So I have 2x squared minus 5x plus 2 equals 0, okay? Now I'm going to see if I can factor this by guess and check. There's no GCF to pull out. All right, so sorry, I was just looking at some notes. I don't know what I wrote down. Doesn't make sense right now to me. All right, so the factors of 2x squared are 2x and 1x. The factors of 2 are 2 and a 1. So it might be a 2 here and a 1 there, or a 1 there and a 2 there. Let's try a 2 here and a 1 there. We have to guess and check to see if that works. That'll be a 4x. That'll be a 1x. If both are negative, that'll give me my -5 that I'm looking for in the middle. And if both are negative, that'll multiply to a +2. So it's factored correctly. All right. So then from there, I set the factors equal to 0. 2x minus 1 is equal to 0. And 1x minus 2 is equal to 0. I'm going to add 1 to both sides. So 2x is equal to 1. Add 2 to both sides, so 1x is equal to 2. Divide both sides by 2, x is equal to 1/2. Here, it's just x is equal to 2. So on my number line, here's 0, 1, 2, 3. Since the inequality does have the bar underneath, I'm going to do a solid circle on 1/2 and a solid circle on 2. I can still use 0 as my test point, okay? Even though 0 is not in between, you can still use 0. And like I keep saying, 0 just makes the math easier. So 0 minus 5, I mean, you can pick whatever point you want. You could try 1. I mean, that would still make the math pretty easy. Plus 3 is less than or equal to 1. So here, this is going to be 0. This is going to be 0. Plus 3 is less than or equal to 1. So this says that 3 is less than or equal to 1. Is that true? No, that's not true. So since this point did not work, since 0 did not work, I don't want to shade to the left, right? That indicates I want to shade in between. Okay, now to verify, because some students will be like, well, how do you know? Like just because 0 doesn't work, how do you know that in between is where you want to shade? Let me show you another test point. If I had chosen 1 as a test point, so 2 times 1 squared minus 5 times 1 plus 3 is less than or equal to 1. So that's 2 minus 5 plus 3 is less than or equal to 1. 2 minus 5 is -3 plus 3 is less than or equal to 1. 0 is less than or equal to 1. Is that true? Yes, that's true. So since 1 works, you want to shade in between. Again, this would be a parabola that's opening like this, and you would be shading in between the parabola. Okay, but we're just not drawing the whole parabola. We're just plotting the x-intercepts. All right. So I think that's it for this lesson and for chapter 3. All right, I'll see you guys back for the next lesson. Bye.